Hey everyone, I'm Michael Unger here at the MacMillan Space Centre, the program coordinator, not at the Space Center, but here in my kitchen. And this is the first of our live Q&As with our astronomer, Rachel Wang. Hey Rachel, how's it going?
Well, thanks.
So every Thursday at 2 p.m., join us here. We're going to be doing these live sessions. Every week, we are going to be doing a theme. Hold on here. I am turn off the YouTube here. Technical difficulty. Sorry about that, folks. I have the YouTube open as I've got the Zoom open. So many things are going on. You know, I've got my TV studio set up here in my kitchen. No problem. So, Rachel, we're going to be doing these live weekly themes. And this week's theme is what's up in the nighttime sky. And I don't know about you, Rachel, but we've been getting some incredible weather recently, which means we've had clear skies. And I've been looking up at the stars every night, and it's been really great. I like seeing the familiar. It's one of those things where the stars that I saw when I was a little kid looking up in my backyard at home are the exact same stars that we see today in 2020, and I find that so magical.
I find that comforting as well. I know I like being able to look up at the night skies and make sure that they're still there.
Absolutely. So we're going to be talking about what you see up in your night sky, but of course you may be in a different location. So it's going to be very interactive. You can use the chat feature on YouTube. Just type in your question. And the first question for everyone watching is, where are you watching from? Type in your location and we can maybe adjust what we're looking at. Of course, we're here in Vancouver. If you're somewhere else in Canada, Toronto, Montreal, even over in Europe, you're probably looking at the same stars that we see, right, Rachel?
Mm-hmm. Yeah, exactly. It all matters about what latitude you're on.
Right, what latitude, which is different if you're down maybe in the southern hemisphere. So I have two nieces that live in Australia. And so all of the stars that we're going to be talking about today, they probably won't know what we're talking about.
No, it'll look a lot different in the northern hemisphere.
All right. Well, here's what we're going to do. Rachel's going to give us a little bit of a presentation about the nighttime sky, and then that's going to take about probably less than 10 minutes. And then the rest of the time, we're going to just get into your questions, which we already have a ton of already. So this is going to be fun. So take it away, Rachel.
Sure, I'm just going to start sharing my screen. So it's going to be a mixture between a PowerPoint and also the UniView software that I use in the planetarium. So that's the same kind of circular fisheye shape that you might have seen before at our last Cosmic Night. So you should be able to see that our topic today is observing the nighttime sky, and in particular, observing the nighttime sky from the comfort of your own backyard. So of course, we'll start with some few stargazing tips to general tips for when you're going out observing, and then transition into our Q&A period. So when you're out observing, and you should be able to see the nighttime sky in the backyard of our Space Center currently at 10 p.m. When you're out observing, what kind of equipment do you need? Now that question really depends on what you're wanting to look at. So the further or deeper in the sky you want to look, the more powerful the magnification you need on your equipment. Now, your eyes are really good for looking at things like constellations or even the Milky Way or some bright planets. And if you were upping your magnification to binoculars, then you'll be able to see things like the details and the craters on our nearest satellite, on our moon. Now, telescopes are really great for deep sky images, so things like galaxies or nebulae. I'm showing you the Crab Nebula right now. And they're especially great for seeing things like the rings of Saturn, which is my favorite planet. Now, you'll want to do your observing somewhere where you have low light pollution. So places like downtown Vancouver are especially bad because there are a lot of lights. Things like street lamps, storefronts, and car headlights all contribute to light pollution. So usually I would head out to somewhere that's a dark sky location, somewhere like Porto Cove or even like Breck Beach. But of course, there are other ways of limiting excess artificial lights in your neighborhood, and I'll talk a little bit about that later. Now, depending on your level of expertise, you'll probably also want something called a planisphere or a Starfinder, or even a Starfinder app downloaded on your phone. And lastly, before you leave, remember to check the weather for cloud cover because you want a clear, dark sky with the best seeing conditions. And I usually use a website called cleardarksky.com to check out the weather at the Gordon MacMillan Southern Observatory at the Space Center or at UBC. And let me really quickly show you how it works. So you should be seeing the Clear Sky Chart webpage right now. What I do is I navigate to this page, I type in Vancouver, and the Gordon Southern Observatory is one of the options that shows up. And then I go over to the left-hand side, display the color legend, and we're really looking for only one of these things here. We're looking for seeing. And so if you go up to the sky and you look at what day you're looking at and at what time, you want to mouse over a little box and it'll give you a score out of 5 as to how good your seeing conditions are, with 5 out of 5 being perfect, you can see deep sky objects very clearly, to 1 out of 5 being poor visibility, or it was just too cloudy to forecast. So that's a really good resource for checking out your seeing conditions before you get outside, just to really make sure that you have the best seeing conditions possible. Now, remember how I mentioned that places like downtown Vancouver were particularly bad for light pollution? Well, in fact, in large Canadian cities, more than 95% of the stars that can normally be seen with the naked eye are actually no longer visible and are washed out by light pollution. So that really speaks to how important reducing light pollution is, especially for astronomical observations. So what can you do? Well, you could organize a neighborhood star party and ask your neighbors to turn off the lights for a few hours. You could also reduce the intensity of lights, adjust their orientation so they're not pointed towards the sky. You could control the length and time of use with things like motion detectors, timers, or even simply turning off the lights before bed. Really, the idea is to only have lights on when you really need them. And finally, you can limit the amount of blue light you use, opting for lights that are more warm, like amber or orange colored. And when you're observing, unless you're specifically looking at the moon, you should try and do your observations during a crescent or a new moon phase. And that way the night sky won't be washed out by a bright moon. So now, how do you find stars and constellations, or whatever object it is that you're choosing to look at? Well, you want to use something called a Starfinder or a planisphere. And we've also provided a link to a DIY planisphere in the YouTube description. You can try and build your own. So now, what is a Starfinder and how does it work? Well, it's a circular map with an overlay that turns to show through this opening the region of the sky that's visible for a specified time, date, and location. And it's really a useful tool for orienting yourself in the night sky, for identifying constellations, and just for generally planning your observing night. Now, as Michael said, not everybody sees the same stars around the world, and what one person sees depends on what latitude they're at. So it's important that you know yours before you buy a Starfinder. Now, for us in Vancouver, we live on the 49th parallel. So for Southern Canada, a Starfinder that's designated for 45 degrees north is perfect. And the way that it works is simple. So you'll see the days and the months of the year around the outer circle, and on the inner edge are the times. And what you want to do is you want to line up the time and date of your observations, and the portion of the sky that you'll see will be shown through this little window here. And all you have to do is make sure that you're holding it above your head and orienting it towards north. So now here's a summary of the stargazing tips. We've discussed the first few, so we're going to just jump right over to dark adaptation. So it's best to give your eyes at least 30 minutes to adjust to the darkness. And we do this in the planetarium too, when we're showing off deep sky objects in our dome. We also use red lights to assist our guests, and we use red because of its long wavelength. The rod cells in our eyes that help us see in low light aren't as sensitive to that kind of long wavelength red light. And that's why night vision goggles are green, because green is the opposite color of red. Now, for telescopes, you'll want to do something similar and let your eyes adjust to the low light. You want to instead let your telescope adjust to the surrounding temperature, and that'll help limit any kind of distortions that you might get. So what can you see in the nighttime sky this time of year? So I'm just going to rewind time a little bit so we go towards sunset. And what's particularly cool is that right now Venus is up and bright in the nighttime sky. you want to look towards the west, and as it starts to set, it'll travel towards the northwest, but it's really cool because it's super bright. It's actually the brightest object in our nighttime sky besides the moon. And if you're a little bit of an early bird like I am, if I fast forward times towards sunrise, you'll also be able to see planets Mars, Jupiter, and Saturn, but those kind of rise and peak around 5 a.m. in the morning. So unless you're a super early bird, maybe stick to Venus, the brightest point in our nighttime sky. Now let's talk a little bit about some constellations. So for us in the Northern Hemisphere, we have a few main circumpolar constellations, and you might recognize them. One of them is the Big Dipper, and you can locate the Big Dipper in the constellation Ursa Major, because the Big Dipper is actually something called an asterism, which just happens to be a group of stars within a larger constellation, and that larger constellation being the Big Bear or Ursa Major. And you can use the pointer stars on the Big Dipper, which is these two stars right here, to find your way to Polaris. And Polaris happens to be the North Star that's in the handle of the Little Dipper, part of the constellation Ursa Minor. Now, another northern circumpolar constellation that I really like is called Cassiopeia, and it's just down towards the bottom of the screen here. It's called the W constellation because it does look like a gigantic W in the nighttime sky. Now, what's also really cool is that you can see not only planets and stars, but you can also see spacecraft. If we were to look through a really high-powered telescope, you might be able to see the details of the International Space Station that looks a little bit like this. What I usually do is I download an app that helps me track when the ISS will be in my region and when I'll be able to see it. You can also go to Spot the Station at NASA's website, and that'll tell you where it is. Now, we just recently passed a nice meteor shower, this Lyrids meteor shower, and that peaked around the end of April. But it's still going on, so you still might be able to catch just a few meteor showers streaking across your nighttime sky. And we also have something very interesting. You might have heard this in the news. Comet Atlas is reaching its closest approach to Earth at near the end of May. And unfortunately, it did break up. It did start to disintegrate into 4 pieces. But with the power of a telescope, you might just be able to catch a glimpse of 1 or 2, or maybe all 4 of those pieces streaking across the nighttime sky. And that brings us to the end of our short presentation. So Michael, I'm going to throw it back to you, and let's get started on our Q&A.
Awesome. Yeah, we've already got tons of questions coming in.
Fantastic.
We'll start with the stargazing ones, and then we'll maybe sort of throw it open to all sorts of topics, because that's what when we're talking about the universe, we're talking about everything. But some of the questions around like the best time to go stargazing, that is a very common question that we do get. And of course, it's all relative. So Rachel, you did sort of tell us that there are planets that are out there. So if you want to catch Venus, that's right after sunset, right?
Yes, right after sunset. I think the best time to go would be around 9 or 10 p.m. I tend to go around 10 p.m. and I find that works well for me. I also like to use a website called Time and Date because it has this really nice night view of the sky that you can track constellations and stars and planets, and it'll tell you when those planets are rising and setting and when the best time to view them is. And I really like to set it to the location of Vancouver so I can see exactly the nighttime sky that I'd be seeing.
Awesome. And of course, you didn't say anything about the moon, Rachel. And of course, the moon is really wonderful. So if anyone wanted to see the moon right now, where would they be able to find it?
If you actually wanted to see it right now, it is up. So it did rise today just after 11, before 12. And, you know, there is that common misconception that you can't see the moon during the day, but we do see the moon during the day for the same reason we see it at night. And that's because it does reflect the sun's light back into our eyes. It is covered with this really fine, almost sandy grain-like material that's white. It's called regolith. And because it's white, it's very, very reflective. So we do have the chance to see it during the day. So if you don't believe me, I very much encourage you to go outside and see if you can see it.
Yeah. Well, I don't know if anyone in the chat is in a different location. I'm here in Kitsilano, and I'm looking out my window, and it's pretty cloudy, so I can't see the moon. But if you're in a different location, go have a look. The moon, as Rachel said, it is up there right now. We could see it in the daytime. Here's some other questions. So maybe looking at, you did talk about the Big Dipper and the Little Dipper, and they want to know, but like really the differences. How do they know if they're looking at the Big Dipper or the Little Dipper?
Oh, sure. I tend to go by size. Also, the Big Dipper just happens to be the one that my eye goes to first. But also using Cassiopeia might be a good way of helping you orient yourself as well, because as we saw on my Uniview screen, Cassiopeia tended to be towards south of the Little Dipper or south of the Big Dipper as well. So that's one way of doing it.
Awesome. And of course, as you can sort of see on my arm here, I've got the Little Dipper. And one way to tell with the two dippers is the Little Dipper, the handle kind of like curls up, while the Big Dipper curls down. So if you're looking, look at the handles. If it curls down, that's the Big Dipper, and the Little Dipper curls up.
We're just going to tattoo like you, Michael.
Oh no, I forgot my mom might be watching this. She doesn't like that. Other questions about the nighttime sky. Are there any deep sky objects that are good for looking at the telescope right now?
Oh, that's a really good question.
Maybe Andromeda?
Oh, Andromeda is always a really beautiful one to look at. Yeah, and that one you can actually see with your naked eye. It looks like a smudge. So having a telescope and looking at that gives you a lot more features.
Yeah.
But it's really cool that that's the furthest object you can see, and it looks like a nice little smudge.
Nice. And here's a really cool question from Cohen Cooper. So if you were on another planet that orbiting around Proxima b, what would the constellations look like if you were on that planet?
Oh, that's a really interesting question. So the way to think about constellations is like you're drawing or connecting the dots between the stars on this sphere. We call it a celestial sphere. So it's kind of like when you come into the planetarium and I'm showing you all the constellations, we're projecting it onto a dome. And it's like these constellations live on that dome. Now, of course, if you're moving towards a different planet, even if you're moving towards a different hemisphere, you'll be placed in a different perspective or a different point of view when you're looking at this dome. And of course, the constellation stars are also always moving as well. So over the next few thousand years, this will also look a little bit different. They're all moving in different directions, even though they look like they're stationary and they look like they're kind of embedded on the celestial sphere. So if we were to travel to a different planet, let's say around Proxima b, then you would have a totally different view of the nighttime sky. But I like to think that maybe if humanity did move to another planet, that we would also come up with different constellations for that planet and different stories to go along with them as well.
Awesome. One thing that you didn't really get too much into was meteor showers, which of course are really pretty to look at, those streaks of light going across the sky. So maybe tell us a little bit about what's happening with those meteor showers. We do have some questions that are related to that as well.
Sure. Yeah, especially because in August we have the Perseids, which are my favorite, not just because they're happening during my birth month, but also because they have a high meteor per hour count. I think it reaches up to between 40 and 60 usually, and that's really cool. And so meteor showers are really coming from this leftover stuff from the trails of comets. Comets you can think of as icy snowballs, and they leave behind trails of debris. And when those trails of debris interact with our atmosphere, they burn up and they light up in our atmosphere. And that's really what we're seeing, those things streaking across our nighttime sky, is this leftover stuff from the tails of comets. And I think that that's just wonderful.
From the tails of comets, that's amazing. Yeah. I love thinking about that. And that's just all this dust that's just floating around there in space. So that brings up some interesting questions people are asking about, Rachel. So we've got all this other stuff in the solar system. Besides the planets, we've got the comets, and we also have asteroids. And people are asking about an asteroid that passed by us kind of close, and of course everyone's a little bit on edge right now, and people like to write about these close passes. Could you maybe tell us a little bit more about these asteroids that are passing nearby us?
Sure, I do get a lot of questions about that. I heard this asteroid's coming and it's barreling towards Earth. Are we all doomed? And the short answer is no. We do have measures in place to detect for when asteroids are coming, just like we have the same thing for satellites. So NASA has a bunch of satellites pointed around our Earth just to make sure we're keeping track of things that are passing too close to us. So we do have an early warning system in place. And to deal with asteroids, if we do have one coming too close, we can do things like fire lasers at them, and that's called laser ablation. And we do something similar with satellites where we're trying to alter their trajectory. So if you had two satellites from two different countries orbiting in low Earth orbit, and they just so happen to be maybe on a collision course with each other, you can always alter the orbit of one to make it higher or lower so they pass by safely. And we kind of do the same thing with these incoming asteroids.
Yeah. So it's one of those things where, like, we really need to be looking out for these asteroids, because they completely wiped out the dominant species, the dinosaurs, at one point. They could wipe us out too.
Yeah. There's a lot of them, right? So we have the main asteroid belt between Mars and Jupiter, and that's really just what we call planetesimals, these leftover chunky pieces of rock that really are the Lego building blocks of our solar system. These little rocks, to form planets, actually, they would smash into each other, and eventually those rocks would clump with other rocks and make bigger rocks, and eventually that rock got big enough to make planets like Earth.
Nice. And we will be getting into that a little bit deeper at the end of June. June 30th is Asteroid Day, and that is a anniversary of the last big impact that happened on the Earth. It was in Tunguska, Siberia. There was no one around, thank goodness, but it left this huge crater, and is a good reminder of this could happen again. So June 30th, we're going to spend a lot of time more on asteroids. But to follow up on what you were talking about with the formation of the solar system, Rachel, we've got a really cool question about the planets and how they orbit the sun all in the same direction in a circular way instead of going all over the place. And maybe tell us a little bit why they're all going the same direction like that.
That's a great question, because you would think with how chaotic the universe is that we really should be living in this chaotic system. Yeah. But it really comes from the formation. So when our solar system formed a really long time ago, billions of years ago, it formed as a swirling pancake-like disk. And in this swirling disk is where we had those planetesimals, those dust-sized chunks of rocks and grains that smashed together. And it was really this angular momentum that this disk had, this turning motion that kept the solar system and the planets orbiting in that rotation. Now, the reason why planets stay in their orbits has to do more with gravity than it does with how they formed. And that really is talking about kind of this idea that our solar system can be thought of as this trampoline sheet, and all of our planets are these little, let's say, marbles or different size objects that are swirling around in it. And if you put something really heavy in the center, a lot of the orbits will start to go around as you give them some sort of initial velocity. So that's really what our planets are doing right now. But it really is this leftover information from the formation of our solar system that causes them to go in a certain direction.
Cool. All right, so we have another phenomena in the nighttime sky. I think the one last thing that I think is probably on like the top 5 list of things that you want to look for, but you can only really see them in certain parts of the world, and that would be the Northern Lights or the Southern Lights. Really pretty dances of light in the sky. Could you maybe tell us a little bit more about what this phenomena is?
Sure. So it really has to do with something called the Earth's magnetosphere. Now, our magnetosphere is from our magnetic field, and it's basically this kind of road that forces particles coming from the sun to follow. And as we have charged particles coming from our sun, they're funneled towards the north and south poles, because that's how our magnetic field is. And when they end up funneling towards, let's say, the North Pole, they get excited when they interact with our atmosphere. So when these particles interact, let's say, with oxygen in our atmosphere, it emits in green. So that's why we have the Northern Lights having that beautiful green color. And what's really cool is that sometimes if our sun is particularly active and it has something called a coronal mass ejection, or a CME, that has it sends a lot of these charged particles towards our Earth, and they still get funneled towards our North Pole, but with all that extra energy, it means that we can actually see it a little bit further down. So we could actually see the northern lights from places like Seattle sometimes when these coronal mass ejections happen.
Cool. All right. So we've only got about 6 minutes left. So maybe we can do some rapid fire through some of these questions. So a follow up on like the Northern Lights.
Yep.
Somebody wants to know if you've heard of Steve before. You know, if
oh my goodness, yes, I do. Steve has to do with the Northern Lights, and I believe it's a NASA-led project. I think, if I recall correctly, has to do with looking at emissions. So like what I was talking about with the excitation of oxygen emitting in green light or green wavelengths. I think they're looking more into that. And I believe it's actually a publicly crowdsourced project as well.
Yeah. No, it's the reason I think the reason they named it Steve was based on a cartoon, I think, because it was sort of like when you don't know what something is, you give it a name, and they kind of just came up with Steve. And for a long time, they didn't know what Steve was.
Steve sounds so familiar.
All right, let's go to some wild rapid fire questions. When are the next astronauts going up into space?
Ooh. I don't know when the next ones are going up to the ISS, but a particularly interesting mission is the Artemis 3 mission that I'm very excited for, and that's in 2024. And that's a particularly big one because they're planning on going back to the moon. And you might ask, well, why are they going back to the moon? That's because they want to build an ISS-like station around the moon called the Lunar Gateway, so they can conduct science whenever they want.
Awesome. All right, here's some more rapid fire questions. Are wormholes real? Are they even possible?
They are theoretically possible. So the proper name for wormholes is called Einstein-Rosen bridges, named after the two people who bashed their heads together and came up with this idea. And I like to think that maybe one day they would be possible, because that would help us traverse really long distances in space-time. So we could visit other exoplanets, other exosystems like TRAPPIST-1. And I think that would be really interesting.
Yeah. Now, the difference between a wormhole and a black hole, maybe talk a little bit about that. We'll get into black holes in a full in-depth session, but maybe just touch on that for a minute.
Sure. So a black hole could be thought of like as an entrance to a wormhole. And a wormhole would really be this, it would be more like a rotating black hole that you could travel through or traverse through safely and end up somewhere completely disconnected, somewhere else in space-time. And I'm going to borrow the interstellar analogy here, where you can think of space-time as a sheet of paper, and if you fold that sheet of paper and poke a hole right through, then you're traversing all of this extra space-time, and it saves you a lot of time to jump between places in our solar system. So maybe either that or warp drive might be the next big thing coming up.
Yeah. And like I said, we're going to have a whole session just on black holes, because we know we have lots of interesting science that has been coming out in the last few years around black holes. We're going to dedicate an entire session just on black holes. I can't wait for that. Another question for you, Rachel. Titan, one of Saturn's moons. Is it a good place to colonize?
So Titan is one of the candidates for maybe it could be colonized, or maybe we should search for life there, because it has these liquid methane lakes on its surface. And what we're really looking for when we're searching for a habitable planet is we're looking for, does it have liquid water or liquids of any kind, really? Is it too hot or too cold? Does it have an atmosphere? Can we grow food on it? Agriculture? These are the things that we're looking for, because these are the things that we know life as we know it needs these things to survive. Now, the thing with Titan is I personally would not want to live on Titan because it does have these methane lakes. Methane is the same thing that makes or is present in cow farts. So I'm sure it wouldn't be the nicest smelling planet to live on.
Right. All right, let's see here. And of course, lots of questions about aliens. So, Rachel, maybe give us a little bit of insight. I know, of course, we are always thinking about life in the universe and the possibility there may be life out there. Maybe give us your take on if there are aliens or life out there.
Sure. I get asked this question a lot. I always say that I'm not going to rule it out. There is a hypothesis that there could be aliens out there. True science means that this hypothesis has to be tested and verified. We haven't got around to the testing and verification yet, but the size of the universe is just so unfathomably big. So our observable universe is 93 billion light years across. And that's just the stuff we can see because it takes light a finite time to travel to us. So there could be a bunch of universe outside of the universe that we can see, and we haven't even been able to look there yet. So I like to say that there's a good chance that there are aliens out there, but I don't think that they've quite made their way to Earth just yet.
Awesome. Well, Rachel, thank you so much. We are going to be back here next Thursday at 2 o'clock. Thank you, everyone on the YouTube channel. So your job for today, you can go into the description and you can get your own planisphere. You can download that and you can go out stargazing. If it does clear up, still cloudy out here in Kitsilano, go find the moon. And then when the sun sets, go find Venus. And if you're an early riser, maybe see those other planets, Mars and Jupiter. And of course, thank you so much for your support. If you can, we are accepting donations so we can continue to provide you this programming. Just go onto our website and find the Donate Now button. In our description on the YouTube page here, you can fill out a survey about what topics you want to hear about next. Any types of programming that you'd like to see, we're going to keep doing this from our homes as long as we can. So please fill out those forms so we can give you the stuff that you want to hear. And of course, you can go onto those resources and look at all the other events we have coming up. Next week, Rachel, we're going to be talking about exoplanets. Is that right?
Yes, and also Monday happens to be a very special day.
Oh, what day is that?
It is May the 4th be with you.
Oh, you don't say, huh? You don't say. Well, I'm going to be really excited. I'm going to be playing with my Star Wars toys. We've got a really great program set up for you on Monday night. We're going to be getting into the science of Star Wars, and we have some special guests from the Industrial Light and Magic, which is the VFX studio that makes all of the special effects for Star Wars. I can't wait. Rachel, thank you so much. I will see you next week. And everyone out there on YouTube land, see you next time.